So, hello and welcome you all in this new playlist we are starting today, and this is named as Understanding Some Basic Concepts in Programming through some questions. And the today's question we were tackling in today is regarding tree. This LeetCode 102 binary tree level order traversal. So let us see what this question will states to us. We have given the root of a binary tree and we have to return the level order traversal of its nodes values from left to right level by level. That means we have to traverse on its levels. First this and store the values in a vector, and after completing one level push that vector into another vector, then again traverse the next level and store all the elements present at that level into some vector, and after completing that level push all the elements of that level into another vector, and also for the further levels as well. And finally we have to return our level order traversal. In this, our each element in this big vector is representing us each level. Zeroth level will contain only one element, that is root. The first level will contains 9 and 20 in this case, and the third level contains 15 and 17 in this case. We have to move from left to right, so we have to move each level as from left till its rightmost element present at that level. So let us code and let us visualize what could be the code for this. We have written our C++ code here. So let us took the example number one. This is our root. Let us point this as our root. Let us take some another color for this root to represent this root. This is our root. This is our root, and our root have a reference for its left and its right as well, and similarly its right references will contain another references for its children's. So what could be the basic approach for this? The question states that we have to traverse on each level through root. In binary trees, we have the only way to traverse on binary tree is to this reference. Through this reference, we can move to its children. Otherwise, there is no way to traverse it at each node if this reference is not there, or if this reference is not given to us. So first we always have to check if this given root is empty or not. That means it is null or not. If this root is null, so there are no element is present in our given binary tree, or no reference is present in our given binary tree, so we could not have anything to traverse. So just return an empty vector from here, and if it has some elements or if it has some nodes, let us initialize our vector of vector res. Here it is a container that contains arrays or vectors in itself, like this, and those arrays or vectors will contain integers in itself, like this. So Let us initialize this as an empty vector, then initialize a QE that will contain a reference for every node. So like this QE will contain elements like this: a node that has reference to its left or that has reference to its right. Basically, these arrows representing us that this node has a reference node present in its left as well and in its right as well. If this left arrow is missing, that means there are no left node present for this node, and if this right arrow is missing, that means there are no right nodes present for the given node. And if both arrows are missing, that means these are leaf nodes, and these this node doesn't have any children's. So what could be the basic approach? First, we will push our root inside this queue. So our root is pushed, that means this 3 is pushed inside this queue, and this 3 have references. This left of 3 has reference for this 9, so this will referencing to this 9 and this will referencing to this 20. So that means this node have references for its left and its right as well. Now while this queue is not empty, let us first check the current size of queue. So our n will contain 1 for first iteration. That means this is this QE will contain only one element, so this n is 1. Initialize an empty vector. So an empty vector is initialized like this, that will contain integer values. So this is an empty vector, that this is temp. Basically name this as temp, temp, and then run a loop for n time. Run a loop for n times for I equals to 0 till I is less than n. So for I equals to 0, that means a loop is start from I equals to 0, and this will check if this 0 is less than n. That means this 0 is less than 1. Yes, the condition for this loop is true, so the cursor will jump into the inside of this for loop, and this tree node reference for named node for this q dot front. That means this, what is the q dot front? Front pointer is pointing to this, and this front is becomes node now. That means this 3 is basically node, and we have to pop out our front from this. So this 3 is removed from our QE. So let us erase this like this, and our QE is empty now. And this is basically, this is node now. So this is node. We have to push this node's value inside the temp. This node value contains 3, so we will push 3 inside our temp, and we will check if this node has any references to its left. Yes, this has a references to its left, that is 9. So we have to push that inside our queue. So let us push like this inside our queue, and the value for this is not 3, this is 9. Let us take another color for this 9, and again check if this node has any references for its left, right or not. Yes, this has references for its right, that means 20. So we will push our 20 inside this like this, and value this time is not 3, it is 20. So let us rename this. Also we will check that this 9 has any references. So this 9 has basically no references, so we will have to delete its references from left and right, but this 20 has references in its right and left as well, so the references for 20 will remain same. And now this I is incremented, so I is now becomes 1, and this one will basically check this time that 1 is less than 1. So no, 1 is not less than 1, so this for loop will terminate, and our current temp is now pushed into this answer. So we will push our this temp inside this, our temp is only this, let us erase this, and this will only contains this temp as 3 as the answer, and these. Now again, when this while loop is checked that whether it is empty or not, whether the queue is empty or not, so queue is still not empty, so again this n will contain the current size of queue, and the current size of queue is this time 2, so this n is now 2 like this, and we will initialize an empty vector named temp. So let us initialize an empty vector named temp like this. So this is temp, that is initially empty. Let us name this. Let us name this as tmp, and a for loop is run from I equals to 0 till I is less than n. That means for I equals to 0 this will run, for I equals to 1 this will run, and when I becomes 2 this will not run. So for when I equals to 0, that means for first time our front is pointing to this, so our node becomes this. Let us make a copy of, let us make a copy for this. So let us make a copy for this and choose this as like that. Now this is node, and pop out, we pop out our node from this, and front is now pointing to this. So front is now this, and this is our node now. We will push this node's value inside our temp. So the value 9 is pushed inside this temp like this, and we will check if this node has any left references. No, it has no left references. So again we will check if it has any right references. No, it doesn't have any right references as well. So this for loop is over now, and this will increment our I, and our I will become 1 now, and this will again check if this 1 is less than 2 or not. Yes, this is less than 2. So again our loop is, we will come inside our loop, and this time our node is, this time our node is this. We will pop out this from our QE, and node becomes this node becomes this, and we have to push this node's value inside our temp. So value 20 is pushed into this temp like this, and we will check if this 20 has any references for its left. Yes, it has references for its left, like that is this 15. So we will have to push our node dot left inside the QE. So we will push like this, and the value for this is this 15. So update our value, this is 15. Also we will take care of the references for this 15, if it has any left references or it has any right references, and we will find out that this 15 does not have any left reference, and it also does not have any right reference. So remove these references as well. So this 15 does not have any left references, and again we will check if this current node is any right references or not. Yes, it has right references, that is this 7. So we will push that inside our QE as well, and we will also take care of the references of this 7, if this has any left or right references, and this has no left references. Also it has no right references. So like this, and now all the lines for this for loop is executed. So this will again come back to this and increment our I, and our I is becomes 2 now, and this will check if this 2 is less than 2. No, this is not less than 2. 2 is not less than 2, so this for loop will terminated, and our current TMP is now pushed into our answer. So we will push our current TMP into our answer. We will delete this, and our answer now becomes 3 in one vector and 9 and 20 in another vector. Now delete this current n and those values, and also when this for loop vanishes, our current node is also vanishes. So delete this also. Now again, this this will come back to this file and check if this queue is still empty or not, and the this will find out that queue is still not empty, it has some elements. So this will store the current size of queue inside the n, and that is 2, and initialize an empty vector tmp. Here it is tmp. Let us name this as tmp, and now for I equals to 0, that means when I is 0, this will check if this 0 is less than 2. If this 0 is less than 2, yes, this is less than 2. So pop out our front node from the queue. So this will pop out and this becomes as node, and we have to push this node's value inside our temp. So push 15 inside tmp. So we will push 15 here, and we will now check if our node has any left references. So we will find out that this has no left references. So again check if it has any right reference, and no, it doesn't have any right references as well. So this for loop is, all statements in this for loop is executed. So this will again come back to its initialization and increment our I is previously 0, so it becomes 1 now, and this will again check if this 1 is less than 2. Yes, this is less than 2, and if this is less than 2, so our for loop is executed, and now this pops out, this pop out the current front of this. That means this becomes node now, and we will push this node's value inside tnp. So push 7 inside this tmp, that means temp, and check if this 7 or this node has any left references. No, it does not have any left reference. Also, it does not have any right references as well. So again, this all statement inside this for loop is executed. So I is again incremented as 2, and when this condition is checked that 2 is less than 2, so this will get false, and for loop it's terminated. So we will have to push our tmp inside the answer. So let us push our tmp inside our answer. like this. Now our answer or vector of vector contains 3 as 0 level, 9 and 20 for first level, 15 and 70 for second level. Now pushing this into answer again, we will have to check if this queue is empty or not, and we find out that queue is empty now. So this while loop is now terminated, and finally we will return this as our answer to the caller. So after executing all the statements, this as final answer is returned to our caller. So this is the basic concept for the level order traversal of a binary tree. It is not necessarily a level order traversal of a binary tree. It is a level order traversal for any graph as well. If we assume that this is not a binary tree but a graph, so the only difference between a binary tree and a graph is that in a binary tree we can only move from upward to downward. That means this parent to child to its parent node to its child node, and in graph we can move in an undirected graph we can move from its parent child to its parent node to its child node, and similarly from child node to its parent node as well. But in directed graph, we cannot move from the child node to its parent node. So we can assume this binary tree as a directed graph as well. So this similar code will work for directed graphs level order traversal as well. We only have to make some changes in this QE collection, whether it is containing a reference for a tree node or any integer as like that. And we will also, in case of a graph, we also have to take care of previously visited node as well, because in case of graphs, we can arrive on the same node in by multiple paths. So this will conclude our today's video for binary tree level order traversal, and let us code this as well if it is running fine or not. Let us copy this code from here and paste this, and check if it is running fine or not. We made a mistake here. What is why it this is running fine but the orientation is not getting correct, and the reason for that, why is it not assigning correct? So basic, let us forget that this is running fine, and this will return us the perfect binary tree level order traversal.